Okay, so this is the beginning of the second semester, so we're going into trigonometry, right? We're done with math analysis. Now we're doing trig, and we're starting with 6.1 in your textbook. Okay, this is 6.1a. So first we're going to be talking about angles and measuring them. Okay, so there are a few vocabulary words that you want to take down in your notes. Okay, angles are made from two rays with a common vertex. And one of the rays is called the initial side and the other is called the terminal side. Okay, so in an example here, this is an angle. One ray would be the initial side, one is the terminal side, and the vertex is that red dot right there. Okay, the measure of the angle is the direction and the amount of rotation from the initial side to the terminal side. Okay, remember, it goes from initial to terminal. Okay, it doesn't go the other way around. The direction is important. The angles are measured in degrees or radians. So there are two different ways to measure them. Okay, so here, if you want to look, we go from initial side to terminal side like this way. So I'm basically going upward, right? Or this is counterclockwise. Okay, and this angle turns out to be 40 degrees. And you guys should know already, degrees are just like little tiny measurement of angles, right? And as the angle gets open wider, the degrees get bigger. And if I go counterclockwise, it's a positive 40 degrees. If I go the other directions, clockwise, it would be negative. Okay, so counterclockwise is positive, clockwise is negative. So imagine if I go from initial side, instead of going up, now I'm going to go down and around. So clockwise, okay, it's going to be like this. So it's going to be a total of negative 320 degrees. Okay, and how would I know that? Well, if you know 40, the whole circle is 360, right? So 360 minus 40 is 320, but I'm going down and back, so clockwise is going to be negative 320. Okay, an angle is in standard position if it is drawn from the coordinate plane, on the coordinate plane with the vertex at 0, 0, so the origin, and the initial side lies on the positive x-axis. So like this. All right, if your angle is on there, vertex at 0, 0, initial side on the positive x-axis, this is called standard position. Okay. Coterminal angles. I know this is a lot of vocabulary words, getting pretty boring, but try to keep track of these. Okay, these are very important. You need to know these things. Coterminal angles, very important. Coterminal angles are angles that share the terminal side, and they got to be in standard position. Okay, they got to share the initial side also. So they share the initial side and terminal side. Basically, they look exactly the same, but they have different measurement. See, so we had the angle that is 40 degrees. Right, so we're finding coterminal at 40 degrees. Well, of course, negative 320 is also the same angle. So they are coterminal angles, right? So the way you do this is you just take 40, subtract 360, and you get negative 320. And why is it minus 360? Because you're going 360, meaning you go all the way around this in the circle one time. So you end up at the same place, right? You start at the terminal side and you go all the way back 360 degrees. You end at the same terminal side. Okay, 360 is just a whole circle. If you walk around a circle, you end up in the same place. So you subtract 360. Or you can subtract 360 two times, right? Subtract 360 and then subtract 360 again, you get negative 680. That is the same angle. It's just a coterminal angle. These angles are basically the same. Okay, they're coterminal. You can also add 360, meaning you walk the same circle, but the other way. So you can add 360, you get 400 degrees. Or add it twice and you get 760 degrees. All these are coterminal angles. All of these angles are coterminal. All right, let's talk about the circle and its measurement in terms of degrees and radians. Okay, so you guys should know, we have a pretty good idea of what degrees are, right? A quarter of a circle is 90 degrees, right? Because the angle there is 90 degrees, right angle, right? Of course. A semicircle is 180 degrees. 3/4 of a circle is 270 degrees, and a full circle is 360. Now we got to learn how to do that with radian. Okay, so radian, it sounds kind of crazy, but it's really not. Imagine you have a circle, all right, and then that's the radius, right? That yellow segment there is the radius. If I take that radius and I lay it on the circle, right? So imagine it's like a string, I cut it, I lay it on the circle. That's how long the radius is. The angle that it makes, we call that 1 radian. Radian is radius. Same thing, right? The length of the radius forms the arc on the circle, and the angle that subtends that arc is 1 radian. 1 radius gives you an angle of 1 radian. Okay, if I do another radius and I put it on there, so I have now that angle. So I have 2 radii lying on the circle, right? The angle comes out to be 2 radians. And that's how we measure it. Let's do one more radius, right? Like that. That angle, what do you think that is now? What that angle is? That angle is going to be 3 radians, right? 3 radians. But 3 radius or 3 radii cannot reach all the way across half a circle. You see it missing a little bit right there, right? That little bit right there is missing. So I have 1 radian, 2 radian, 3 radian. The missing bit right there, how much do you think that is? Right? You might have guessed it's 0.14, approximately 0.14. So together, it makes what? 3.14 radians, or pi radian. That's where the pi comes from. Okay, that's where we got pi. Pi is not a magical number. That's exactly how they found pi. They took the radius and they see how many radii do I need to go across half a circle? It's pi, 3.14. So half a circle. Oh, by the way, that's why the circumference of a circle is 2 times pi times radius, right? Because you go halfway is pi, so all the way across, all the way around the circle is 2 pi times however long the radius is. That's why you got circumference formula. Anyway, so half a circle is pi radian. So 180 degrees is equal to pi radian. That means 90 is pi over 2. 270 is 3 pi over 2. And 360 is 2 pi. All right? That's just what radian is. How many radians it takes to go around the circle, 2 pi radians. All right, converting between degrees and radians is pretty easy. Going from degrees to radian, you just multiply by pi over 180. So here's 35 degrees. How do I convert that to radian? I multiply by pi over 180. Remember, the whole point of multiplying like this is so you can cancel out the degree, right? Degree times degree at the bottom, cancel. And then 35 over 180, you simplify, you get 7 over 36 pi. Easy enough. Here's another, 105 negative degrees. Multiply by pi over 180. You got to be able to cancel out the degrees. So degree, cancel with degree. 105 over 180, simplify that, you get negative 7 over 12 pi. If you convert from radian to degrees, you do the opposite. You multiply by 180 over pi. You flip it upside down. So the whole point is that you can cancel out the pi, right? So you multiply by 180. So pi on top, now I have pi at the bottom. Cancel pi and pi. And then you just multiply and then you simplify. I get 130 degrees in this problem. All right. Finding coterminal angles in degrees and radians. All right, if they give you 60, like we did earlier, right? If you want to find coterminal angle, you want to just go around in a circle. So in a circle is 360. So I just add 360, right? I get 420. If I want another one, I add another 360. I get 780. If I want to go backwards, I subtract 360 and I get negative 300. That's a coterminal angle too. They're all coterminal to each other. Or I do it again, subtract 360 twice, and I get negative 660. In terms of radian, same idea, same concept, okay? If you want to go in a circle, how many radian do you need? 2 pi. All right. So I'm going to add 2 pi. So 7 pi over 5, add 2 pi. I can't add 2 pi, right? I got to make it common denominator. So 2 pi means 10 pi over 5. So this 10 pi over 5 here is just basically 2 pi made into common denominator. So I add that, I get 17 pi over 5. If you want to do more, go in another circle, add another 10 pi over 5. I get 27 pi over 5. You want to get negative, you subtract 10 pi over 5. I get negative 3 pi over 5. Or do it twice and I get negative 13 pi over 5. The whole idea is if you want coterminal angles in terms of radian, you add or subtract 2 pi and change it to be common denominator so you can do it. That's all. All right, determinant of two angles are coterminal. So this angle and this angle, are they coterminal? If they're coterminal, the difference between them has got to be the full circle. So 360 degrees. So I take one, subtract the other. I get negative 360. Yes, they are coterminal. Another example, 45 and 350. Take one, subtract the other. I get negative 305, not coterminal. Right? It's got to be 360. In terms of radian, you subtract them and you should get 2 pi. Right? Full circle is 2 pi. So 2 pi means they are coterminal. If you get something different, then they are not coterminal. Okay, here you find an angle theta. Okay, you guys gotta get used to the symbol here, the Greek symbol. This is called theta. Okay, we use this a lot to represent angles. Okay, so the angle theta in the specified range that is coterminal with the given angle. So see what that means. They give you an angle and they want you to find a coterminal angle in this range, right? Greater than 0, but less than 360. So you want smaller, right? You're going to go down from 1200 down to 360. So you got to subtract. All right, find coterminal. So you subtract 360, and you subtract it a bunch of times until your answer is within that range. So in this case, I need to do it 3 times, and I get 215. And that is a coterminal to this in this range. All right. Same thing for pi or in radian. Here I have a negative angle and I want it to be positive in this range. I got to add, okay, I got to add 2 pi. So add 2 pi, and 2 pi means 12 pi over 6. Earlier it was over 5, so I have 10 pi over 5. Now it's 12 pi over 6. Okay, you add it a bunch of times until you get into that range. So I add it twice and I get 7 pi over 6.